So hello friends, today we are going to solve chemistry unit 5. The paper code is WCH 15/01 and the topics are transition metals and organic nitrogen chemistry. And you can read these instructions, information and advice. I'm on section A. Let's say the first question is, this question is about transition metal complexes, the the bonding within the complex. This is so the bonding within this complex is, there is no ionic bond. Okay, there is no ionic bond, so A is not the correct answer. The only covalent and only dative, no, it has both covalent as well as dative bond, so the B is correct answer. Now B part, which complex is tetrahedral? So this one is square planar. This one is it's like copper, and 4 OH groups, 4 H2O group, H2O groups, and 1 OH group. So it's nothing but square bipyramidal. This is also a square bipyramidal. We can replace this water molecule by ammonia and this OH by water. So the fourth one, cobalt tetrafluoride, is the correct answer. It has a tetrahedral complex. Okay, now see which complex contains bidentate ligand. So the one is A option. The nitrogen has one lone pair, this nitrogen also has one lone pair, and this nitrogen also has one lone pair. So the total is 3 uh, ligands present here, so therefore it is tridentate. uh, Ammonia and water both are monodentate, and so therefore it's a monodentate. Okay, now in this, here it is one nitrogen and here it is one nitrogen, so two nitrogen, so it's a bidentate, and the D1 is hexadentate, so the correct answer is C. Second question, a hydrogen oxygen fuel cell is used to prevent electrical energy for an electric motor in a car. The first A, the electrolyte in fuel cell is acidic. What is half equation at anode? So as we know, at anode oxidation takes place. So at anode oxidation takes place. Okay, therefore the only option C is oxidizes from 0 to +1 H plus. So the correct answer is C. Now option B, question B, hydrogen oxygen fuel cell have advantages over methanol oxygen fuel cell in vehicles. So which of these is advantages? Which of these are advantages of hydrogen oxygen fuel cell? So the very one first advantages is, this methanol oxygen produces CO2 group. Okay, this produces CO2, and this CO2 cause the climate changes. Okay, cause climate change, but hydrogen oxygen fuel does not, so the emission does not contribute to climate change, so the correct answer for B is B. Question 3, an electrochemical cell is made from the electrode system shown by these half equations. What is happening here? Ag plus is taking one electron and becomes Ag solid, silver solid, and VO2 plus aqueous and two hydrogen, uh, 2H plus aqueous plus electron is converted into VO2 plus aqueous and water liquid. So this is reduction. Okay, it's a reduction. So we will reverse this equation, making silver solid is converting into Ag plus and removing one electron. So it is what? It is oxidizing. So it is oxidizing, and then we will add, because at anode oxidation and at cathode reduction. So here it is reduction, or this is for oxidation. So when we will change the sign of it, so this will become minus 0.8. So E cell will be what? E cell will be E cathode minus E anode. So it's 1 minus 0.8. So it will be positive 0.20. So see, which silver compound could be used as electrolyte in left hand half cell? So the answer is silver nitrate, because it is soluble and the rest of these molecules are insoluble. Okay, the electrolyte in the right hand half cell is prepared using equal volumes of this 2 mole decimeter acidified this and 2 moles per decimeter cube of acidified VO2 plus. Now the C is, which is the equation for the overall cell reaction under standard condition. So as we know, we changes this, that Ag solid is converting into Ag plus and this electron, and VO2 plus 2 hydrogen and plus 1 electron is converting into VO2 plus and water liquid. So when we add this, so this electron and this electron would cancel out, or in the left hand side we will have VO2 plus, okay, VO2 plus VO2 plus, okay, 2H plus, so 2H plus and Ag solid. So this Ag solid, and the left hand or in the right hand side Ag plus, okay, Ag solid and Ag plus aqueous, VO2 plus aqueous and water liquid. So the correct answer is B. Now we already solved this, which is the value of E cell in volts. So E cell is calculated E cathode minus E anode. At cathode the value is 1, at anode the value is 0.8. So, and we take always oxidation values, okay, sorry, reduction values, because oxidation values is minus 0.8 but the reduction is this, so 0.8, it will be positive 0.2. So the D answer is C. D, correct answer is C. Now E, which is the cell diagram for this cell using conventional representation half cell. So we write left hand side for anode, Okay, this is for anode and this is for cathode. So at anode oxidation takes place, or at cathode reduction takes place. So Ag solid. Okay, correct, but that should be reduced. So V2O plus, okay, water, V2O plus water, liquid, aqueous. Okay, yes. So this is reduced to this. Okay, this symbol is not used. This is a comma to represent this. So the correct answer is B. Now, question 4. A mass of 4.179 gram of hydrated iron 3 sulfate. This was dissolved into deionized water and solution made up to 200 centimeter cube. What is the concentration of sulfate ions in the solution in decimeter cube? So for finding the concentration of this, we need to find the number of moles. So how we can find the number of moles? This divided by the molar mass that is given to us. Okay, so the given mass divided by molar mass. And why I multiplied this? Because I need to find out the mass of this Fe2SO4 in this compound. That's why total mass was this and minus the mass of water. So you will get the actual mass, the anhydrous mass of iron 3 sulfate, because it's a mass of hydrated. So you have to remove water molecule. So the mass is this. And now I need to find out the number of moles of this. So how I can find the number of moles? I have to use, when I solve this, I get the given mass of FeSO4, Fe2SO4 as 3.999. Okay, so the mole will be, molar mass is 399.9. So the moles is 0.01 moles. And because it can be written as 2Fe, breakdowns in 2Fe, Fe plus 2 and okay, plus 3, and this is SO4 minus 2 times. So this is 3. So the total moles of SO4 minus 2 will be 3 times of this. So the mole will be 0.03. And now I have to divide by this 200 decimeter cube, and after that I have to make it into decimeter cube. So divide by 1000. So divide this number by 0.2 and the final answer will be 0.15. So the correct answer would be D. Question 5. The infrared spectrum of compound X is shown. Okay, this is a wave numbers, which could be compound X. Okay, so it is here it is carbonyl group, and here it is OH group, and in between it's a carbon, so it has carbonyl group and OH group. So yeah, this C double bond O and OH group. So the correct answer is A, because none of them has both. It's having OH bond but no C O O, C double bond O bonds. Okay, C double bond O it has C double bond O but not OH bond, or this one also not having OH bond. Now question 6, methyl benzene reacts with a mixture of concentrated nitric acid and concentrated sulfuric acid to form 2,4,6 tri-nitromethylbenzene. Okay, so what is the number of peaks in 13C NMR spectrum of methylbenzene? So here are different carbons. This is 1, here is 2, 3, 4, 5. So the total is 5 peaks can be seen. Okay, now what type of reaction takes place? So in this, as we know, concentrated nitric acid and concentrated sulfuric acid, when react together, it produces NO2 plus, which is an electrophile. So now the electrophile is substituted here, so the reaction takes place is electrophilic substitution. Okay, now which expression shows the mass in gram of 2,4,6 tri-nitromethylbenzene formed from 10 grams of methylbenzene if yield is 85%. So for finding this, we need to find the number of moles of number of moles of methylbenzene. So how we can find the number of moles? 10 divided by 92. So now this is the mole of 10 methylbenzene, and the same moles will be produced 2,4,6 trinitromethyl. And so if we know the number of moles and the molar mass, so it will be amount, the mass, and it is 85%. So I have to multiply this 85 and divided by 100. So the actual equation would be 10 multiplies 85, 227, and divided by 92 and 100. So this is the correct answer, A. Now 7. The mass spectrum of compound shown is obtained using a high resolution mass spectrum. So what is the mass to charge ratio m by z of molar ions of this compound, molecular ion? So first we have to count the number of carbon in this. So the 1, 2, 3, 4, 5, 6. 6 carbon. Number of hydrogen 1, 2, 3, 4. 4 hydrogen and 1 oxygen. So this is the molecular formula of this compound. Now I need to find out the MR of this. So 12 times 6 plus 4 times this 1.0078 plus 15.9949. After calculating, we will get 92.0261. So the correct answer will be A. Now question 8. A group of students carry out an experiment to find the concentration of chlorine Cl2 aqueous in a solution. Aqueous potassium iodide solution is added to 10 centimeter cube sample of chlorine solution. Okay, the iodine produced is titrated with, this iodine is titrated with solution of thiosulfate ions of known concentration using the starch indicator. The concentration of chlorine aqueous is in between this to this. What is the concentration of thiosulfate ions in mole per decimeter cube is required to give a titrate of approximately 20 centimeter cube. So the concentration of this is given. So this and this in 1:1, 1:1 ratio. So I suppose this is 0.04. So this will also be 0.04, and it is 1:2. So it will be 0.02. And now this is produced or reacted with this. So as this is 0.04 and it is multiplied by 2, so I need to have this at 0.02. So now see what is color change at the end of the titration. So at the end of titration, blue black to colorless solution, color changes. Question 9. Formula of 4 ions are shown. Okay, 4 ions are shown. And how many of these ions contain metal with oxidation number of +3? Metals with oxidation number of +3. So see, chromium, CrO4 2. So oxygen has -2. So overall minus, and this is 8 times minus. So x plus minus 8. Okay, x plus minus 8. So it will be 6. So this chromium has 6 charges. Okay, positive 6 charges. Now aluminium, it is x plus -4 -1. So it will be +3. So 1, and here Fe. This is Fe, Cn minus charges. So x -6 -4. So x is equal to 2. So this is also not, this is also not. Now chromium, this has 0 charges. So chlorine, x plus -2. Okay, x then -2 and is equal to 1. So 3. So how many? 2. So the correct answer is B. Now the section B. This question is about silver and silver compounds. Glass decoration are made reflective by coating their inner surface with silver. This is achieved by using reaction between silver nitrate solution, ammonia and glucose under alkaline conditions. Initially, the colorless complex ion diamine silver 1 Ag and NH3 twice forms. So explain the shape of this. So the shape of this is like HNO NH3 Ag HN3 or bracket plus. So the shape of this, the shape of it is linear, and angle between them is 180. Okay, and having two bond pairs, this and this. So two bond pairs, and why it is like linear? So to minimize the repulsion between these two bonds. So therefore it is linear. Now explain why Ag HN H NH3 Ag NH3 twice plus is colorless, because in this complex Ag has in +1 state. So the oxidation electronic configuration can be written like this: 1s2 2s2 2p6 3s2. So everything is filled, even the last d orbital is also completely filled. The silver ion has a fully d orbital, so no dd transitions can be take place. Therefore no color can be shown, therefore it is colorless. Now diamine silvers, one complex then react with glucose forming silver and organic compound Y. Two other compounds are also formed. So the complete equation of this reaction is, this is glucose, so 2 times of this complex and 2 times OH when reacted to produce Y plus 2 moles of silver and 4 moles of ammonia and water. Now we have to draw the structure of this molecule. So we can draw the structure of molecule 6 carbons. So 1, 2, 3, 4, 5, 6 carbons. Now we have to attach 7 O. So 1 OH, 2 OH, 3 OH, 4 OH, 5 OH, 6 O, 7 O. Now we have to add 12 Hs. So 1, 2, 3, 4, 5, 6, and here is 1. So 7, 8, 9, 10, 11, or it's 12. So 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9, 10, 11. Okay, here is 2 hydrogen, so 12. Okay, so the overall reaction in silver cell used is in watch batteries is this is, and the half equation for the reaction at a positive electrode is this. So what we can do, we will reverse this reaction. So when we will reverse this reaction, this and this will cancel out. From liquid, this will cancel out, so it will be Zn plus zinc solid plus 2 OH molecules to give Zn OH and 2 electrons. So this will be the final equations. Question 11. Chlorophenamine is a amine used in the treatment of high fever. Okay, so we have to mark this as a group. So deduce the classification of labeled amine group. It's a tertiary because it is connected with 3 CH groups. See, methyl, this is methyl, this is methyl, and this is complete. So it's a tertiary amine. Now see question B. So compound pyridine is used in the synthesis of chlorophenamine. Like many amines, pyridine is miscible with water and the solution formed is alkaline. So alkaline, why? Because pyridine is an organic base because it has a lone pair on nitrogen and water. So nitrogen lone pair, and this nitrogen lone pair is donated to water's H. Okay, so it forms a hydrogen bond between nitrogen and hydrogen. So when nitrogen hydrogen bond takes place, what will happen, it can take completely a 1 H plus from this water molecule. So the reaction will be like OH and here it will be plus, and solution will left with OH minus, and because of this OH minus, solution will become aqueous. Okay, a student suggested that final step in the synthesis of chlorophenamine starts with the reaction between mono dismethyl chlorodis and chloromethane ethane. Assuming the reaction is similar to that between ammonia and chloroethane, complete the mechanism of this reaction. Some of organic structures shown have been simplified. Include curly arrow and any relevant dipoles and lone pairs of the electrons. So what happened here? Amines has nitrogen lone pair, and this chloromethane has delta positive. Okay, this chloromethane has delta positive, so this lone pair will attack on this carbon and Cl will remove. So when this attack on this, nitrogen forms 4 bond, therefore 1 plus come on the nitrogen, and after that this bond is given to nitrogen and H plus is removed. Now this H plus is combined to this Cl minus to form HCl, and this product is formed. This question is about polymer. The diagram shows part of the structure of polymer formed by a condensation reaction between two amino acids. Okay, so this is here. So this bond is formed when what happened to it? Water molecule is released, means, and this from here nitrogen and nitrogen. So this water molecule will release and this bond will form. So predict the structure of two monomers that produces this polymer. It means, so one monomer should have the carboxylic group and another monomer should have this amide group. So when they react, so water will remove and they combine together. So we can make this. The diagram shows a repeat unit of an addition polymer used in some food wraps. It is formed from two different monomers. Okay, this is formed from two different monomers. Deduce the structure of two monomer that produces this polymer. So how this polymer can be produced? By these two formulae. Okay, here 2 chlorine and this is a single chlorine, so one will be this and second will be this compound. A synthetic rubber polymer has the structure shown. This is a synthetic polymer. The molar mass of synthetic rubber is approximately 3 lakhs gram per mole, means 300 kg per moles. Calculate approximate number of repeat units in the polymer. So for finding the approximate repeat units, I need to find out the molar mass of this single unit. So first I will count number of carbon atoms. So 1 2 3 1 2 3 4 5 6 7 8 9 10 11 12. So 12 carbons and 2 3 4 6 8 9 10 11 12 13 14. So 14H. So what will be the MR of this repeat unit? 12 into 12 and 14. It is 44 plus 14. So it is 158 grams. And now divide 3 lakhs gram by 158 grams. So the number comes about 1898.7, and which can be written 1899. So about this much repeat unit should be there. So approximate number of repeat unit in the polymer. So it is almost about 1900 units. Now, hydride of arsenic and arsine is a toxic gas used the production of semiconductors. Draw a dot and cross diagram of arsine AsH3. So As, this has the 5 electrons in their last orbital. So 2, 3, 4, 5, and the 3 electrons from hydrogen. So overall this will complete their octet, 8 electrons. B part is arsenic is reducing agent and react with cerium 4 sulfate solution forming arsenic. The data from an experiment are shown. Volume of arsenic gas is 350 centimeter cube, which we can make in decimeter cube. So 0.35 decimeter cube, or 350 into 10 raised to minus 6 meter cube at Pascal this, and the temperature is this, so we have to convert into in Kelvin. So 293 kelvins. Okay, volume of cerium 4 sulfate solution is this. Concentration of cerium 4 sulfate solution is given. So first of all, we have to write the half equation of arsenic hydrides. So the arsenic plus 3 H plus and plus 3 electrons. Now calculate the final oxidation state of cesium ion formed in the reaction. So first, for finding that, we have to calculate the moles of C plus cesium Ce4 plus. So the volume is this and concentration is given. So volume multiplies concentration will give the number of moles. So when number of moles is this and temperature is in Kelvin, our volume is in this. So we can use PV is equal to nRT, and PV divided by RT is number of moles. So after calculation, we find out the moles of arsen is this. Ratio is what? 0.049 divides by 0.049 divides by 0.0 this. So it is almost 3:1. Okay, so the final oxidation state is cesium plus 3. So describe the reaction of separate samples of aqueous cobalt 2 sulfate with aqueous sodium hydroxide, excess aqueous ammonia, and concentrated hydrochloric acid. For each reaction, link your description to appropriate equations. State symbols are not required. The first, first cobalt color changes. Okay, so the first is pink solution changes to blue solution. Okay, this is changes from pink to blue solution, and after that cobalt sulfate aqueous solution. So aqueous cobalt sulfate, it will form a complex CO, and its coordination number is 6, therefore 6 OH and 2 plus. And because we are adding with with aqueous sodium hydroxide, so OH minus, it will give 2 water molecule will remove here and this will add here. So cobalt H2 H2O4 and OH minus OH2, and the charge will nullify because plus 2 and the 2 minus will come here, so the charge will nullify, and 2 water molecules. And now we are adding excess aqueous ammonia. So what will happen here in this step, the water molecule will remove, and this ligand will remove and ammonia NH3 will come. I'm sorry, uh, I was doing this reaction H2O, and here it will form CO NH3 4 NH3 6 plus 2 4 water molecules plus 2 OH minus. And now we are adding concentrated HCl, which form dark blue solution. Okay. Okay, and the last reaction again will be cobalt water 6 2 plus 4Cl minus aqueous to give cobalt tetrafluoride, okay, plus 6 water molecules. So now question 15. A compound Q contains the element carbon, hydrogen and oxygen only. Combustion analysis: 4.91 grams of Q produces 14.6 grams of carbon dioxide and this much gram of water. Show that the molecular formula of Q is this. Okay, so MR of Q is 148. So the mass of carbon in this, okay, the mass of carbon in Q in 4.9 grams. So mass of carbons, so it is around 3.982 grams, and the mass of hydrogen is the number of moles, this divided by 18 and multiply 2, because the molar mass of hydrogen is 2, so it will 0.398. So the total, and the mass of oxygen will be 4.91 minus total, 4.91 minus this, so it will be 0.53 grams. Now we have to find out the number of moles of these individual atoms. So carbon divided by their atomic mass, hydrogen divided by their atomic mass, and oxygen divided by their atomic mass. So the number of moles, okay, moles comes this 0.033, 0.398, 0.332. So I have to divide the smallest one, the whole. So the smallest one number is this 0.033, divide this number by all. Okay, so it will around 12, or it will be around 10. So hence formula will be C10H12O1. Okay. 16. Benzoic acid is a white crystalline solid with structure this. It is found in many plants as it is an important building block of biosynthesis of a variety of compounds such as plant hormones and attractants for pollinators. The role of benzoic acid in the chemical industry is also widespread, and approximately 5 lakh tons are produced annually. It is used in the synthesis of many compounds, including medicines, dye, and insect repellents. Such synthetic dyes are often classified these days in the range of. The synthetic involves the formation of diazonium ions. This is the reaction between the phenol, the coupling reaction, and to form a dye. The relative simplicity of the reaction involves the ready availability of starting materials, makes azo dye cheap to produce. Salt of benzoic acid such as calcium benzoate and sodium benzoate are used in the food industry as preservatives. So the reaction starts from benzene and bromine with FeBr3. So when this happens, when it is, so it forms bromobenzene. So what it forms? It forms bromobenzene. After formation of bromobenzene, we are going to use Grignard Mg triether, and Mg triether makes what? It will become MgBr. MgBr. And after formation of MgBr, we are using CO2. So CO2 has the structure of like this. It means this carbon is filling delta positive, and this is metal. Mg is metal, so it will always be positive. If this is positive, so this is delta negative. So what will happen? This will attack. Okay, this will attack on this carbon, and a compound will be formed like this. This is the carbon 1, and the carbon is making 1 2 3 4 bonds, so one bond will break down, and at O it will be minus, and MgBr, M at M is positive, so it will combine like this. Okay, it will combine like this, and now we are adding HCl, or as we know, this is act as both. It can act as nucleophile as well as base. but it has a property. It will act first like a base and then nucleophile. So if there will be any acidic hydrogen, so it will first act as base rather than acting as a nucleophile. So we are taking here acid which has H plus. So before it act as nucleophile, it will act as base, and acid and base reaction takes place and it will form this. It can take H plus from here and it will remove, and finally the product will be, byproduct will be MgClBr. B part, benzoic acid can be used in the synthesis of azo-dyes. In step 1, benzoic acid reacts with concentrated nitric acid to form 3-nitrobenzoic acid. Okay, this and this. So as we know, concentrated HNO3 and concentrated H2SO4, when combined, it form, okay, N2 plus. So the reaction takes place here like this, and it is an electrophile. This one has electron withdrawing group, so the attacking side is, okay, meta. This is ortho, this is para, and this is meta. So at meta it will act from here on nucleophile, and inside or at benzene it will be positive. So now this hydrogen will give its bond to the benzene, so this plus will nullify and remove in H plus form, and this nitro benzoic acid will be formed. So steps 2, the 3-nitrobenzoic acid to form 3-aminobenzoic acid. So the state the reagent required for this reaction. So which reagent we should use? So we can use tin or concentrated HCl. Step 3, 3-aminobenzoic acid reacts with sodium nitrite and dilute hydrochloric acid, forming a diazonium ion. So when these two reacts and it forms diazonium ion, so this happens at a very low temperature. Okay, state a temperature at which this reactions should takes place, giving one reason for your answer. Temperature should be in between 0 to 5 degrees Celsius. And why the temperature should be low? Because to prevent the formation of byproducts formed, draw the structure of diazo azo-dye formed when the diazonium ion reacts with phenol. Okay, diazonium ion reacts with phenol here, this, or reacted with phenol, so this compound will be formed. Now hydrated calcium benzoate is used as a preservative in soft drinks. It has the formula this: 2.6 gram of hydrated calcium benzoate was dissolved in deionized water. Excess lead 2 nitrate solution was added, forming a precipitate of lead 2 benzoate. The precipitate was removed and dried. The mass of dried solid was this. Calculate the molar mass of hydrated calcium benzoate, and hence deduce the value of X. Okay, So we know the dry mass of is this, so we have to find the moles of it. So for finding the moles, I have to divide this mass by its mr. So its mr is about 4.49.2. So this will be the number of moles of this one, and the same number of moles will be for calcium benzoate hydrated ions. So I need to find out the mr of this. So what I can use, mr of this can be finded out by the number of moles multiplied mass. So number of moles is 3.894.92 and multiply the mass. So the mass is 2.6. Mass is 2 point, okay, sorry, I used the wrong. Moles is mass divided by mr, and I need to find out mr. So mr will be mass divided by number of moles. Okay, so mr is this and 2.6, and this divided by 3.89 multiplies 4 this. So when we will use calculator, it is coming around 300.24. So this is the molar mass of hydrated calcium benzoate. Okay, now I need to use this formula for finding out the value of X. Okay, the calcium plus 6 carbon, 6 plus this 7 carbon, 2 oxygen, and 5 hydrogen multiply 2. So 7 carbons, 2 oxygens, 5 multiplies 2 plus X times 18. Okay, plus X times 18, and this is equal to 300. So 20, and this number is 7 multiplies 12 plus 2 multiplies 16 plus 5 and plus or whole multiplies 2. So 242 plus 20, 242 plus 18x 300. Now this 18x minus 300 and minus 300 minus 300 minus 262. So it is 38, and now divides by 18. 38 divides by 18. So X is about 2. My bad, I am wrong here. Mass of calcium is 40, not 20. That is atomic number. So mass of calcium is 40. Mass of calcium is 40. So it is 82. So that will be 18. Okay. 300 minus 82, it will be 18, and divide by 18. So it is 1. Okay. So the value of X is 1. Thank you for watching the video, guys.